So last but not least, we'll look at pollution from oil. And as mentioned during the energy chapters, oil pollution has occurred. It's been fairly widespread and fairly significantly over the years, from the Exxon Valdez to the BP Gulf oil spill. And the problem with oil pollution is that it can have catastrophic environmental impacts. Petroleum products are highly toxic to many marine organisms. So, for example, for birds, which you may have seen videos on the news and so forth of using, say, Dawn dish detergent to clean the feathers of birds and even to clean mammals as well. The birds are they're weighed down by the oil, so they can't fly, but they can also ingest the oil, which will lead to death, obviously. Mammals, the same kind of thing. There are marine mammals that have, they have fur as opposed to feathers, but again, they can get into their system and cause them to ingest the oil, and that also will lead to death. And fish, obviously. One of the bigger problems is that algae and microorganisms will ingest this oil, incorporate it into their tissues. They form the base of the aquatic food chain, so then as other organisms eat them, they are made sick as well. So, for example, in the Gulf of Mexico, the shrimp that were normally there were not only affected by the oil directly themselves, but by what they were ingesting. So, how does this oil get into the water? It can come from offshore oil platforms that are drilled for undersea oil. An example of that is the BP in the Gulf of Mexico. In North America, we have about 5,000 offshore oil platforms, and there are another 3,000 in other parts of the world. The New England coast actually has been approved for offshore oil drilling. That hasn't happened yet, but we do need to keep an eye on that because these oil platforms are not pretty to look at. Certainly not as pretty as a wind turbine, and again there can be oil spills from them which contaminate our water, and here in New England we're very dependent on our water for our economy, so that would not be a good thing. Petroleum products can also enter oceans as spills from oil tankers. So Exxon Valdez is one of the famous cases where a single-hulled oil tanker was traveling in Alaska, and the tanker hit, I'm trying to remember now what it exactly hit, but it hit a shoreline, a shallow area, and the oil, a tremendous amount of oil was spilled directly into the waterways there. Again, killing, just like in the Gulf of Mexico, killed everything from mammals to birds to fish. So since the Exxon Valdez accident occurred, ships that enter U.S. waters are now required to be double-hulled, so that if the outer hull is breached, the oil is contained inside another hull, another protective tank, so that the oil does not get into the water in that case. So what happens when an oil spill pollutes water? There are several mechanisms which are used, and more were tried out during the Gulf oil spill. One of the main ones is a containment boom, and it's a boom that floats along the surface of the water to keep the oil from floating away and dispersing, so that it can then be a more focused cleanup effort. These containment booms, though, only go so deep. They are typically like a balloon that then that then may have strips of an absorbent material, a fabric material hanging down from them, but they still don't go very, very deep. They are good for if you have an oil tanker crash or something like that, but they don't help very much with things like the Gulf oil spill. A second method that's used is adding chemicals which break up the oil, dispersing it before it hits the shoreline. So the key pro here is before it hits the shoreline, so you don't have those contaminated beaches and so much mammals and even some of the birds. But the downside is that these are chemicals. They are dispersing the oil, but they're not making the oil go away, so it's still present even though it's in tinier parts that can be diluted. A third way, which has been researched actually for a number of years now, about 30 years, is releasing bacteria that are genetically engineered to consume oil. So that has some pros. They consume the oil, then the oil's not floating around. But a couple of the concerns are these are genetically modified bacteria, and it's possible that there would be a biodiversity issue where they might be present in larger numbers even after the oil spill is gone. And the other problem is if something feeds on the bacteria, then they are simply moving, again, the oil basically up the food chain. Okay, so a nation's water quality is a reflection of its water laws and their enforcement. And I'll just briefly mention a couple of water laws. So the first one in 1972 was the Clean Water Act. And the point of the Clean Water Act was to protect fish, shellfish, and wildlife, as well as human recreation in and on the water. And through the Clean Water Act, water quality standards were established to define what the acceptable limits of various pollutants in U.S. waterways included. So it said how much of a certain pollutant can you find in a pond, a bay, a river. But one of the lacking points here is it did not include groundwater. And groundwater is used extensively by people in the United States for drinking water. So later, first in 1974, and then some amendments after that, or revisions after that, was the Safe Drinking Water Act. And that set up standards or limits for safe drinking water. And that is run through the EPA, and it is responsible for establishing what maximum contaminant levels for 77 different elements or substances, including bacteria, can be present in both surface water and groundwater. So 77 is a lot of elements. You don't see them all show up on your water quality report from your town unless the common ones are reported, but the other ones that are less likely to have been positive aren't reported, just for making it easier for you to look at your water report. But if one of these not typically reported elements or substances is present, then it is reported in the water quality report. Okay. Let's look at some of the maximum contaminant levels, or MCLs, for typical contaminants in drinking water, as determined by the EPA. And these are all in parts per billion. So that means that these are really nasty things to have in your drinking water. If you want such a small amount that you only want to have 1 part or no parts, or maybe 2 parts per billion, that's a very low threshold. So one is Giardia. Giardia causes intestinal distress. It's very hard to cure once a person has that. So we do not want to have any Giardia in our drinking water. Fecal coliform is things like E. coli, any type of similar bacteria that is found in the intestines. You don't want to have that in your drinking water either. Arsenic, which I mentioned, can be toxic to humans as well as other organisms. It has a slightly higher threshold, but still you can see it's very toxic if we want such a low number in there. Mercury, as I mentioned already. Benzene, which is an organic chemical, and atrazine, also an organic chemical. You don't want to have those in very high quantities. Overall, the water laws, these two main water laws, have very successfully attained their goals. So you can see that many streams have started, streams, lakes, ponds, bays, and estuaries are now fully supporting their designated uses. I still wouldn't go swimming in the river in New York, for example, New York City, but they've certainly come a very long way. And you can read through the charts later, see what the impairments to the various sources were and where it came from and what we've cleaned up. I want to add in here briefly a bottled water reality check. So before you look through and read through all the slide, let's just talk about bottled water. First of all, it comes in plastic containers, and these plastic containers are polluting our waterways. Secondly, it's very expensive, and thirdly, it's not any better than the water that comes out of your tap. So let's look at some of the numbers. Bottled water, it can be 500 to 1,000 times the cost of tap water. And Americans spent $15 billion buying bottled water in 2007. And sadly, that number has not improved very much, though there has been some improvement in more recent years as people are starting to understand the environmental impact that bottled water has. And the other part about bottled water is that a quarter of it is actually ordinary tap water that's just bottled into bottles for ease of distribution. It's not any cleaner or healthier than the water coming out of your tap. About 40% of bottled water is actually contaminated. So the water actually, the standards for water quality in bottled water are actually lower than the water quality standards set for tap water, and that's still true today. Sadly, only 14% or sometimes 15% you'll read of bottled water is actually recycled. And that's just not a good thing. Okay, to produce water bottles, and to fill the water bottles involves a lot of energy use. First, the materials from the bottled water, the plastic, comes from fossil fuels. That's the original material that's needed to produce plastic. It takes a lot of energy to turn that into plastic, a lot of energy to turn that into a bottle, a lot of energy to fill, and then a lot of energy to transport it. Bottles of water are very heavy, so transporting them across the country from one location to another causes a great deal of pollution that doesn't have to happen at all. Okay. So if you haven't already, do consider taking a little more time and energy to use a reusable water bottle. Okay, so just a quick review of the key concepts. Water everywhere, but usable water is very rare, not a drop to drink. Our water comes from groundwater, and that body of water is known as an aquifer. Some places get their water from surface waters. We use and overuse fresh water. Agriculture, the biggest user, followed by industry and household use. And within household use, silly things like flushing the toilet use the greatest percentage of our water. When we alter the availability of water by dams or aqueducts, that has consequences. Do review the various types of water pollution. Don't forget there are things like water